Okay, on this video for Prison Break, we're going to look at the horizontal asymptotes. We're going to look at application here first. What I need you to do is pause the video and read this before I start talking about it, because I'm not going to read it because my voice hurts. So pause and read. Okay, on this problem, he's coming, we got our prisoner, he's trying to get out of this place, so he's coming up and down this ladder. And these are the givens. They tell you that the tower is 35 feet tall. So we actually need to write that in because that's not written on our picture. Now, notice what I did up here. This is getting into similar triangles back from geometry. So what I did was actually pull this apart. This little one is this little one here, and this big one is this whole thing. Okay? So if you look at it as two separate triangles, this is what you're given. This is y, and this is 7 here for the prisoner. And then for the tower, it's x, which we now know is 35 because they give us that. But this right here, this is the big mistake I see on tax, and it'll probably on STAR too, is that we want to put 12 right here, okay? 12 only goes from here. If we're talking about the big triangle, it's actually 12 plus y. So be careful of that. So what we're trying to do here is set up a proportion to find the length of the inmate's shadow when the guard was at the top of the tower. So if he's all the way at the top, we're looking to see how long this shadow is. So back last year in geometry, you'd set up a proportion. So if we set up our proportion, it'll look like that. 35 over 7, we did that because the height of the tower, let me go back, sorry. Because the height of the tower and the height of the prisoner are proportional. So they did 35 over 7 equals, and then the other length is the 12 plus y and the y. So you want the 12 plus y to go with the 35, and you want the y to go with the 7. So if we do 35 over 7, we're going to do 12 plus y over y here. Now, what I'll see a lot on, the mistake I'll see the most here when we set up these proportions, we'll just put 12 here, okay? Just this distance from here to here because that's what's given. The distance is all the way across. So it's going to be 12 plus y. So when we try to solve this for y, of course it's proportion, so we're going to cross multiply. So I'm going to do 7 times all of that and 35 times all of that. So when I distribute, I'm going to get this right there. 84 plus 7y, that's what I get from here, equals 35y. Then when I solve, I need to move my y's together. So when I do that, I get 28y. Then the last thing, of course, is divide by 28. And so I get y equals 30. So the inmate's shadow would be 3 feet long if he was all the way up at the top. Okay? So just a little reminder about how to do similar triangles. Now, down here, we're going to look at the graph. Right here, they talk about how this is the function that would represent that situation. So when we graph it, the graph looks like that, and we'll look at it on the graphing calculator in just a minute. But actually, let's do that right now. So if I pull up, if I go to my website, or if you don't have your graph calculator at home, remember you go to the website, it'll pull this up. It's in the links. You got to look for it. It's not at the very bottom. You got to find it. Graphing calculator. You can plug that in, and then when you graph it, so you use this for other things too. If I hit graph, it's going to give me this. Now I can't see all that the way I want to see it. So if I zoom out once, I can see it a little bit better. If I zoom out again, I can see even better. Now, the graph on the worksheet here and the graph on the graphing calculator look different. Well, because it's a real world example, we don't need this mess down here. So just keep that in mind that you don't need this. We're only looking at this right here. So it actually does look like what we have on the worksheet. Now notice this calculator online, it actually graphs this vertical asymptote here. So let's think about why there's a vertical asymptote at 7. Well, if we go back to the worksheet, the horizontal axis represents the height of the guard. So why is there a vertical asymptote at x equals 7? Well, because he's 7 feet tall. He's not going to be shorter than that. So that's why our graph has that asymptote there. Okay? Now, if we put in our function, and we go to the table, where is table? Oh, it's right here in front of me. Sorry. Okay, if I come down here, is this going to work for me? This table will start giving you the points you want, and you can put in, remember, you can input any number you want in there. So if you want different numbers, you can put the number in here, just punch it in, and it'll give you the number that goes with that. So on the worksheet, I want you to pause and input those numbers, what you get. All right, so this is what you should have gotten for those values. Sorry. So make sure you have that graphed. Make sure these numbers make sense to you. All right, and then one other thing over here where it talks about the domain. Why is that between 7 and 35? Well, it starts at 7 because he's 7 feet tall, so you're not going to have less than 7 for his height. And why does it stop at 35? Well, the tower is only 35 feet tall, so obviously he's not going to get to go higher than that because there's nothing to climb there otherwise. Okay, so that's talking about the domain a little bit. All right, so the last question down here says, determine the functions asymptotes, explain their meaning in the problem. All right, so let's think about the first thing. Solving the denominator equal to 0, that'll give us our verticals. Of course, because that's x minus 7, when you solve it, you get x equals positive 7. So that's our first vertical, that's our vertical asymptote. Now, when the guard's lantern reaches 7 feet, the inmate's shadow no longer touches the ground, okay? Because he's touching the ground. Because the function has a higher degree on the denominator than there is in the numerator. Of course, this is 1. This has a degree of, let me fix here. This has a degree of 0 up here, right? And this has a degree of 1. So we're going to have a horizontal asymptote, excuse me, at y equals 0. Because when the denominator is bigger, you have it at y equals 0. So make sure you understand that. If the guard could go higher than 35 feet, the inmate's shadow would keep getting shorter, shorter, and shorter. Okay? All right. All right, most of this next page is review, but at the bottom I'm going to go over something that's a little bit new. So don't just stop watching it because you think it's all review. All right, on this one right here, locate the vertical asymptotes. When you do that, of course, we're going to set the denominator equal to 0. All right? Determine the horizontal asymptotes. You're going to compare the degrees of the numerator and the denominator. Do that first, and then that way you go back to your little rules. To find the determine the points of discontinuity, find where the factors in the numerator and the denominator that cancel. Okay? And plug the value in the simplified function to determine the point. This is the part we hadn't done. We've done this, the canceling part, but not this. So this is going to be new. Of course, you're going to draw the asymptotes with dotted lines because they're not actually part of the graph. And then we've done the table, so we'll look at that and graphing it. All right. Now, everything in this screen we've already done. We've factored 3x squared minus 10x minus 8. Remember, for those of you who weren't with me first semester, it adds to negative 10. This is b, and this is a times c. So 3 times negative 8 would be negative 24. So I'm going to look for my factors of negative 24 that make negative 10. Well, obviously that's going to be negative 12 times 2. That will give us negative 24 and then add to give us negative 10. So when we do that, that's going to be x minus 12 times x plus 2. And then we got to go back and take care of the leading coefficient, which in this case is 3. So I got to divide this by 3 and this by 3. So the 12 divided by 3 just cancels to x minus 4. Okay? But 2 over 3 won't reduce. So we're going to actually rewrite this. So 3 has to come up. So this is actually 3x plus 2. So that's a little bit of review of that. 2. Okay? How they got this up here. All right. So we've done that. We know the vertical asymptotes we can't determine. We got to cancel first. Anything will cancel, right? And so this is our vertical asymptote. X plus 4 equals 0. So we have a vertical asymptote. X equals negative 4. Okay. So, let me erase that. I messed that up. Try again.